and welcome back to the new data structure and algorithms series. So today we will start with two-dimensional arrays. Hope you have completed the first. Before starting 2D arrays, let us find out a way to count an element in an array or in any given list. So what I mean to say if you have some numbers in an array, right? Say its base starts from 25 and it's 26, 27, 28, 29, right? And if you want to count number of elements, as we can see, it is 1 2 3 4 5, right? But there is a very basic formula: 29 minus 25 plus 1, right? So this will give you 5 elements. So the basic formula is, this will be helpful in 2D arrays, that's why I am saying last element, right? To count a number from particular point, starting point, to particular end point. So first you write last element minus first element plus 1, right? This will be the number of elements in given list or array. This is the basic formula. Okay, so now I will start with 2D arrays. Say we have array like, say I have elements 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So this is like 4 cross 4, right? In mathematics we have read about matrices, right? So it looks like this only. So how we declare it? If I say the name, if I keep the name of this array as A, so I will write A 4 comma 4, right? So this first 4 means number of rows, right? And this second 4 means number of columns, right? In 2D array, right? So it should not be like it is always a square matrix type of thing. You can write 4 cross 3 also, right? So if I want to store it as 4 cross 3, okay, let me make it 4 cross 3. So this will look like this. Okay, I will write 4, then I will write, sorry, 3 cross 4, right? 3 rows and 4 columns, right? So this is like first row, second row, third row, first column, second column, third column, fourth column, right? So to make the audience clear that it should not be always a square matrix, we can declare array size like this. Why we can do it like this or in any order? Because in memory, this is like how user reads the array, right? But in memory, how it is being stored? In memory, it's being stored like this only, right? So this will give you the correct explanation also of not storing it like 2D array. In memory, it is like state chunk and you are storing it like this. I will show you how, right? So I will write first rows element, right? So it is 11, 12, 13, 14, then it will be 15, 16, 17, 18, and then either 19, 20, 21, 22. So see, we are declaring a two-dimensional array like this, but in actual, in computer memory, right? So in computer memory, it will look like this only, right? So computer have its own logic how to calculate the things as row wise or column wise. To make you understand, I will mark it with red. This is first row, right? 1 2 3 4. So this will end first row. 1 2 3 4. This will end second row, and 1 2 3 4. So this is our first row. This is our second row, and this is our third row, right? Say your array, I have named it with capital A, so I will write it like this. So say first memory location of this array is 2000. So since from last class I am taking, this is an integer array, if you want to declare it, you can write int a and say 3 comma 4, this will be proper declaration, and then you can give the elements, right? I will tell you how to give the elements. First I will explain you how it is being stored in the memory, so that you should be able to access the location actually, which we have learned in the last class, right? So I have told you, if it is an integer array, from last class example I am taking it as of 2 bytes, so it is 2000. Then this will be 2002, this will be 2004, 2006, 2008, 2010, 2012, 2014, 2016, 2018, 2020, and 2022. So one more thing about addresses I want to make you clear. So if I am saying the element 21 of array, right? So its starting address is 2022, and this array will end at, means last address will be 2023, right? Because it is of 2 bytes, right? Right? So first byte address is 2022, second byte address is 2023. That should be simple, right? Like in for element 21, first element's address is 2, first byte address is 2020, then second byte address is 2021, right? Okay, now this is saying first row, second row, third row, right? Now if I have to access, like, and this is how it is being calculated in memory also. If I have to access the location of say this element, say I want to access location of the element 20, right? So what I will do, what I will do is I will fill in this blank also, how actually you declare the array in the memory, right? 2D array, right? But first we will see how to access 20 here. So I know the address of 20 is 2018, right? Now I am developing a procedure in which I can find out the actual address, right? How to get into that. So I will write it like this. Location of, this is third row and second column, right? Location of say name of array is A, third row, second column, right? See, if you want to reach till here, you need to cross two rows, right? You need to cross two rows, right? First row and second row, right? How we will cross that, right? How we will cross that? If I need to cross two row, what I will do? Take the row position in which this element is. That position you will get from here, right? That is third. So take that row position 3, and then how many rows you have to, what you say, skip? So I will I need to skip two rows. So what I will do? 3 minus 1, right? Then I will skip two rows, right? This is the basic procedure actually, right? The place from where you started, right? And the place from till which you have to reach, right? So what I have done, third row, right? So to reach till third row, I have to skip two rows. So what I will do, 3 minus 1, right? This is basic row formula. And why I am showing it here 3, because it will be related, right? I will develop a formula then, right? Now that is fine. I have to skip two rows, fine, but I have to skip every column of that row also, right? Right. So if first row is having four columns, then I have to skip four columns, right? Because to reach till 20, how many elements I have to skip? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So how we reach till that conclusion, that I am trying to tell you, right? So what I am trying to say, if I want to reach, if I am skipping two rows, So anyway, I have to check how many elements I am trying to say, right? How many element I am trying to skip. So in two rows there are one, two, three, four, right? Four columns. So what I will do, I will multiply with number of columns. What it will give? It will give the number of elements which you have skipped in two rows. See, 1, 2, 3, 4, 5, 6, 7, 8. Right? It is giving eight elements. Right? Then I have to take number of columns also. Right? So plus number of columns. How many columns are there? I have to reach till second column. Till second column means I have to skip for one column only. Right? So this is 2 minus 1, right? And this is exact column address, so I don't need to multiply any row because that thing I have done in here also, right? So this will give you idea of number of elements which I have to skip, right? I will take one or two more example, right? So I will write it bit on the left side. So location of 3 comma 2 element in 2D array, right? Then I have to write base address. Say it that is 2000. This is the base address. And this is like number of rows I have skipped with every row, number of column, how many column it is having, right? And then at the point where I have to reach that column one I have taken, this measure I am taking for this thing, right? And then the size of data type. This is 2. So let's calculate how it comes. 2000. 3 minus 1 is 2. 4 2 ka 8 plus 1. This is 1. 9 to 18. Right. So 2000 plus 18. Right. So this is how your computer calculates the address actually. Right. The location of 3 comma 2. The similar kind of formula we have developed in last class also for 1D array, right? But this is how our computer gets the addresses, right? What I will do, I will do in here one more example to make this formula much more clear. Then we will generalize the formula, right? Say I want to calculate, or our compiler wants to calculate the location of, if you want to take this name, then take this name, so then you make it small, so I'll keep it capital here also, right? Say I have to check the element 17, right? This 17 one, right? So it is at second row third column, second row third column. So now quickly write the base address 2000. Second row, so number of rows I have to skip actually to reach till second one, right? So what I will do, 2 minus 1, right? So this thing corresponding to row actually, right? I will link it there, right? And this thing corresponds to column actually, right? I will take tedious examples of competitive exam also in this. So 2 minus 1, it is 1, right? Now number of columns, it is having 1 2 3 4, 4 columns, so multiply by 4, right? Then add what I need to add, number of columns, right? So at which column I need to go, third column, right? This is third column. So what I will do, 3 minus 1, right? And then size 2 byte. So 17th address is 2012. So let's see whether it is matching. 2000 plus 2 minus 1 is 1. So this is 4 plus 2 into 2, 12. So 2000 plus 12. This is 2012, right? Which is the address. This is how you see it is being saved in memory as a linear chunk of memory. We are treating it as 2D array. But this is how computer calculates the location, right? Why we need location? Then we will do star and we will go to the value of that place. Fine. So this is how 2D array is being placed, right? in general, in most of the exam also, or in any competitive exam also, or in any interview also, how he will refer? He will give you start address, right, of your array, right, means start address of your column, right. Before proceeding further, I will tell you the way we have stored it in the memory gives its name, right. So the we have stored it in the array in row wise, so this is called row major order, right. And C programming follows row major order, right. So this is being followed by C programming, right. So what is column major order? So column major order, if we store this array column wise, right, I will write down here the column major order for it. So it will be stored like this. We will be storing the column like 11, 15, 19, this is first column, then 12, 16, 20, this is second column, 13, 17, 21, this is third column, then 14, 18, 22, this is fourth column. So if we are storing the array in memory column wise, that will be called column measures. This is not much being followed now. So how the location will be calculated here, that we will see later. First we will get this concept actually very firmly. So I will take one previous year question. Okay, so what I there is one point which I may want to make here. Our array, the starting row number is 1, starting column number is 1, so that's how this formula is being coming here very nicely, like 2 minus 1, 3 minus 1. So I will take one previous year question. So with the help of that I will tell you how what I am trying to say. So the question is, your array is given from minus 5 to 5, means row number is starting from minus 5 to 5, not 1 to 3, and column number is also starting from minus 5 to 5, right. So suppose array is stored in memory in row major order. Base address of the array is 999, right, and size of the data type, that is written as C. What is C? Size of the data type is given as 10, and it is being asked in the question, find the location of A00, right. So I think I have made the question clear. Find the location of A00. This type of question usually come in different exams also. So how we will calculate it? So see, A00 will not be its first element. Why? Because our column number is starting from here, right, minus 5 to 5, right. So how we will calculate it? It's very simple. Location of A00, base address 999 plus zeroth element location, right. So no, row number is 0 minus starting row, that will be minus 5, right. And then this should be multiplied with number of columns. So how to get a number of columns, right. So number of column, how you will get, or number count of arrays elements or list element. This is, that's why I have given you formula at starting. How we will calculate number of columns? Number of columns will be last column 5 minus first column minus 5 plus 1. So there are 11 columns in there. So here number of columns is 4, because we could calculate it directly, right. If we want to apply this formula here, what we will do, 4 minus 1 plus 1, that is 4, right. So I will put down 11 here, right, then plus then I will write plus 0 minus base address of means starting number of column minus 5, and then size, in here it is being given 10, so I was using 2 in the example, right? 999 plus what this will become 5, 11 into 5 is 55, plus this will be plus 5, right, into 10, so 999 plus 60 into 10, 600. So if we add this will be like 991,599 will be the address of or location of A00. Analyze this formula. So say you have given an array with lower base 1 to lower base 2, right? Or rows address starting from LB1 to LB2, right? Not address count, and columns UB1 to UB2, and say you want to check address of AIJ, right? Location of AIJ, right? Let's assume C is the size of data type, and BA is base address, right? BA is base address, right? So we will generalize it like this: base address plus, if it is stored in row major order, right? Row major order I am speaking. Base address, then I minus LB1, because this corresponds to row, multiplied by number of columns, plus this thing will be J minus starting number of column multiplied by C, right? This looks like bit tedious, right, to write down, right? But it is very simple, which we have seen in the example. The formula turns out to be like this, right? This is how we should do this formula. Fine. I will look at column major order, right? So since I have already told you, I will take the same question again. 11, 12, 13, 14, 15, 16, 17, 18, 19, or say 20, 21, 22, right? These are the element of an array, right? And what will be the number of rows? A3 and 1 2 3 4, A3 comma 4, this will be the size. So how this is being stored in column major order? So let's write it quickly, right? So first column is 11, 14, 17, right? Then your second column is 12, 15, 18. Third column is 13, 16, 19, and fourth column is 20, 21, 22, right? So till this point your columns are there, right? So I will erase this space. Okay, anyway, I'll draw it again, right? So this is how you will get your number of, this is your column major order, right? Say address are 2000, so it will be 2002, 4, 6, 8, 10, 12. This is 2012, right? 14, 16, 18, 20, 22. right? So this is 2022 last addresses, right? So say if you want to check out location of a, you say 15th, right? So this is in second row and second column, a 2 comma 2, right? So now in this case, since it is being stored in column measure order, you have to skip number of columns, right? Number of columns, then each element in that column, right? The only difference is that, right? A22 is 15, this element, right? So if you want, I will write this is first column, second column, third column, and fourth column. See, you have to skip number of columns in here, right? If it is stored in column measure order, number of columns. So skip number of columns, right? So and then you will reach till this is first column, right? First column. So it is in second column, right? And then with every column you have to skip number of elements in a row, right? If you are coming from here to here, then how many elements? One, two, three, four, five. Actually, it is on sixth position. So one, two, three, four, five elements I have to skip, right? So how I will write it? I will write the column one. So this is 2 minus 1, right? So this is 2 minus 1. And then how many rows are there, right? There are one, two, three. So multiplied by 3 rows, plus now it is in second column, where is column is starting from 1 1 1, right? 1 2 3, 1 2 3 4. So it will be 2 minus 1 and multiplied by size. Size is 2 bytes only, and say it is having base address as 2000. See, 2 minus 1 is 1, 3, right? And 3 plus 2 minus 1 is 1 into 2 plus 2000, right? So it is 2008, right? So the only thing which has been changed in here is this thing represents now number of rows, right? How many rows you are required to skip, right? So since you have understood row measure order, column measure is very easy, right? And this is, so since I have taken is 2 cross 2, what I will do, I will take this element. This will be 3 cross 3. So I will not take even number, I will take this element, then 3 cross 4, location of element 3 comma 4. See, so what I will try to write now, right? This 2 is being related in here actually, no? So now you will get the idea, right? So 3 cross 4 is element 20 22. So your address should come as 22, right? So this was bit obvious, it was 2 comma 2. So directly it is 2008, value is coming correct. Now we'll check it like this. So here number of column is 4, fourth column, 4 minus 1, starting address, starting point where column is starting, multiplied by number of rows. How many rows are there? Now here 1 2 3 multiplied by 3, plus this is 3, 3 minus 1 multiplied by size plus base address, right? So it will be like 4 minus 1 3, 3 3 ka 9, 3 minus 1 2, right? And this will be 2 plus 2000. So 9 to 11 22, it is 2022, right? So the only difference which comes in here, so this is being calculated correctly, right? If the array is stored as column measure order, what you have to take care, you have to skip number of rows now. If it was stored in row measure order, you have to skip number of columns here, right? Number of columns here, right? So that's why now if it is stored in column measure order, you have to skip number of rows here, right? Number of rows, 3 rows in every column, right? Here number of columns in here, right? So 4 columns in every row. So that's how this formula is being built. Now if I write that formula, that also fine. if I don't write, then also it is fine, but still I will write it here, in here only. If this thing is being calculated as column measure order, right, don't confuse it with it, right? You have understood the concept, you apply that concept only, right? Just for the sake of it, I'm writing, if I'm finding a of I comma j in column measure order. So what will be the formula? Base address plus, now you see, j minus ub1 multiplied by number of columns plus I minus lb1, and this whole multiplied by c, the size, right? So this will be only change, right? This will only be the change in here, right? Just you have to write number of columns, right? So since I have explained row measure in very detail, because it is like, what to say, it is being used actually, right? But if someone says, or in some exam, or if in any competition, if someone says I am storing my array in column measure order, so you have to multiply it with number of rows here, right? Number of rows, right? I have mistakenly written number of columns, it will be number of rows here, right? Just multiplied with number of rows, right? Because I have to skip number of rows, right? And in here, if it is row measure, so multiply with number of columns and you will get into that, right? So in next lecture, I will be covering triangular arrays, right? So thanks for your patience. So let's meet in the next lecture. Thank you. Bye bye.